Way, way out there, hundreds of millions of miles from us, orbiting the giant planet Jupiter, there's this small, icy moon. At a glance, it kind of looks like a cracked porcelain ball, right? But underneath that frozen shell, Europa is hiding what might be the biggest secret in our entire solar system, a massive, hidden ocean. You know, we've been staring up at the stars forever, asking that one huge question: are we alone? We've built these giant radio telescopes to listen for signals and sent rovers to kick up the dust on Mars. It's one of the most basic things about being human, that curiosity. But what if we've been looking in all the wrong directions? What if one of the best shots we have at finding life isn't on some faraway Earth-like planet, but on a moon, right here in our own solar system? What if the answer has just been waiting for us, hiding under a thick sheet of ice this whole time? Okay, now this is the part that's just wild. Europa is actually smaller than our own moon. But get this, scientists are pretty sure its hidden ocean has twice, that's right, 2 times the amount of liquid water as all of Earth's oceans combined. Just let that sink in for a second. Twice our planet's water, all tucked away inside this little icy world. So you're probably wondering, how in the world can we be so sure there's an ocean there? I mean, it's not like we've sent a submarine. Well, the answer is this incredible story of scientific detective work, putting together clues that we've been gathering for decades. The whole story really unfolds over time. It all started back in the 70s with the Voyager probes. They flew by and noticed that Europa's surface was weirdly smooth, not covered in craters like our moon. That was the first hint. Then, in the 90s, the Galileo spacecraft found the smoking gun, this really strange magnetic signal. And then, just in the last decade or so, the Hubble telescope saw what looked like giant geysers of water literally erupting into space. Every mission gave us another critical piece of the puzzle. That magnetic signal was the real game changer. So think of it this way. Jupiter has this massive magnetic field. As Europa orbits through it, if there's a big layer of something that can conduct electricity under the ice, like, say, a global ocean of salt water, it would create its own little magnetic field in response. And that's exactly what the Galileo spacecraft detected. And this isn't just a wild guess. It's based on hard data. When you look at what Galileo saw, the best and really the only explanation that fits is a planet-wide ocean of salty, liquid water sloshing around right under that ice crust. And if that wasn't enough, then you have the plumes. The Hubble Space Telescope actually saw what looks like water vapor shooting out from Europa's surface, reaching heights of 200 kilometers. To put that in perspective, that's more than 20 times the height of Mount Everest. It's like a potential fire hose connecting that hidden ocean directly to space. Incredible. Now, the evidence isn't just in these invisible magnetic fields. It's literally written all over Europa's face. That surface isn't some dead, static sheet of ice. No way. It's a dynamic, shifting, cracking landscape that tells us there's a powerful, restless ocean churning just below. Remember how Voyager saw almost no craters? Well, that's a huge clue. See, on a dead world like our moon, impacts from asteroids and comets leave craters that stick around for billions of years. But on Europa, they get paved over. Something is constantly resurfacing the moon, erasing the old scars, and that something is almost certainly fresh ice and water from the ocean below. And this whole resurfacing process creates some of the most bizarre places in the entire solar system, like this stuff called chaos terrain. And honestly, it looks exactly like it sounds. Like someone took a giant hammer to the ice, smashed it into huge pieces, let them float around like icebergs, and then just froze everything solid again. So here's how scientists think this chaos terrain gets made. First, a big blob of warmer water or maybe slushy ice rises up from the ocean. As it gets near the surface, it starts to melt and crack the frozen crust from underneath. And then, these huge chunks of ice, some of them are the size of cities, break off and float around before everything freezes back together in that jumbled, chaotic mess. It's direct proof that the ocean and the ice are interacting. Okay. So we've got a massive, active ocean. That's amazing, but it all leads to the biggest question, doesn't it? Could something actually be living in there? To figure that out, we have to see if Europa has the essential ingredients for life, at least life as we know it. So when we're searching for life anywhere else, we're basically looking for a recipe with 3 key ingredients. First, you need liquid water. Second, you need the right chemistry, the basic building blocks like carbon, sulfur, stuff like that. And third, you need an energy source to power it all. All right, let's go down our checklist. First up, liquid water. Does Europa have it? Oh, yeah. Big check. We're talking a global ocean with twice the water of our entire planet. That's about as big a check mark as you can get. Next, essential chemistry. Well, those reddish-brown streaks all over Europa's surface, scientists think those are salts and sulfur compounds that have been zapped by Jupiter's radiation. If that stuff is cycling from the surface down into the ocean, and you've got minerals coming off the rocky seafloor, then yeah, all the necessary ingredients should be there. So let's give that a check too.
And finally, energy. Europa is way too far from the sun for sunlight to be the answer. But it's constantly being squeezed and stretched by Jupiter's immense gravity. All that friction creates heat inside the moon. It's called tidal heating, and it could be enough to power hydrothermal vents on the seafloor, just spewing out chemical energy. And that means we can check off the final box. Europa has it all.
Now, this is where it gets really mind-blowing. Right here on Earth, in the deepest, darkest parts of our oceans, we have these hydrothermal vents. There's no sunlight, it's under crushing pressure, but they support entire ecosystems of life that run purely on chemical energy. If Europa has similar vents on its seafloor, and all the signs point to yes, could it also be supporting its own deep, dark biosphere? The parallel is just, it's too perfect. Now look, for now, this is all just really, really good evidence. To get the real answers, we have to go back. And that's exactly what is happening. We have a mission on its way right now, designed specifically to figure out if Europa could be a home for life. This is not science fiction, this is real. NASA's Europa Clipper mission actually launched in October 2024. It's on its 6-year journey to Jupiter right now. When it gets there in 2030, it won't orbit Europa itself. The radiation is just too intense. Instead, it's going to make over 40 close, swooping flybys to scan the moon in more detail than we've ever seen before. So, what's it going to do on those flybys? Well, it has 3 main goals. First, it's going to confirm the ocean is there and figure out how deep and salty it is. Second, it's got ice-penetrating radar to map out how thick that ice shell is. And third, and this is the most exciting part, it's going to try to fly right through any of those water plumes it finds to directly taste the ocean's chemistry and look for complex organic molecules, the very signs of life. So what does all this mean? It means that within the next decade, we could finally have an answer. And finding life on Europa would be so much more than just finding some alien microbes. It would prove that life can start up all by itself, twice, in the same solar system. And if that's true, well, it suggests life isn't some rare, precious miracle. It might be a common cosmic process, just waiting to be found in hidden oceans all across our galaxy. It would absolutely change everything we think we know about our place in the universe.